This video talks about how to find the reliability using different continuous distributions. So the first distribution is the normal, and the reliability is defined as the reliability at time period t is the probability that a product or a part will last longer than t. So the probability that the product has a life longer than t. And if you map this to the normal distribution curve, this is like the area above t in the normal distribution curve. So in Excel, we use 1 minus the cumulative distribution value at t. Okay. So the problem 16 says that using normal distribution, determine the reliability at 6,000 cycles, the t, of a switch with a mean life of 5,500 cycles. So this is the mean life, the central line of the distribution, and the standard deviation of 165 cycles. So the sigma is 165, and therefore the reliability at time period t is 1 minus the norm dot dist, and then the first parameter is the t, second parameter is the mean life, third parameter is the standard deviation, and the last parameter is true. So we want to find the cumulative distribution, and therefore it returns 0.001222. So this is a very small reliability. That means very small portion of the product will actually last longer than 6,000 cycles. And next we use a Weibull distribution. So use the Weibull distribution for exercise 16. So we still use the values here, but then instead of a normal distribution, we want to determine the reliability using a Weibull distribution when the slope of the Weibull is 3.5. So the beta value is 3.5. Still, this t is 6,000. We still want to find the probability that the part will last longer than 6,000 hours. And then the mean life is still 5,500 hours. Cycles. And now what is given for the shape of the Weibull distribution is the slope parameter, which is 3.5. So to find the reliability at time point t, we can use the Weibull.dist, the Weibull distribution function in Excel. So in Excel, it actually gives different names for those parameters as we defined in the textbook. So you do not have to go with the names on Excel. You just follow what I write it here. You use this sequence to put in the parameters as what we defined in the class. So t is the time point where you want to find the reliability, beta is the slope, and theta is the mean life. Okay, so now we want to use the Weibull function, which is 1 minus the cumulative distribution of Weibull at 6,000 cycles. So then that will be Weibull.dist, and then the first parameter is the t, second parameter is the slope, third parameter is the theta, mean life, and then you select true for the last parameter, and therefore it returns us 0.2576889. So this is what we got using the Weibull function, a built-in function in Excel. And the formula is not that complicated, so we can also use the exponential function to compute the RT value. To use the exponential function, we should first compute what is in the exponent. So this is t divided by theta to the beta. Okay, this beta is to the power of t over theta. It is not t over theta times beta. Okay, so we want to first find what is on the exponent, and that will be 0 minus the t over theta, and then to the beta. So this is what is on the exponent. And then to find the RT, we use the exp function, which is the exponential function in Excel. And then the number we need to put is C9. is this pre-calculated exponent, the power. And then that gives us 0.2576889 as well. So you can use either way to compute the RT. And next we're going to talk about the exponential distribution. So this is we use problem 17 as the example. Determine the reliability at t equals to 80 hours, 125 hours, and 160 hours respectively, when the mean life is 125 and there is a constant failure rate. So what is given is the theta is the mean life value, which is 125. So in Excel, the exponential distribution function only takes lambda, the failure rate, as a parameter, and therefore we have to first compute the failure rate, which is 1 over the theta, 1 over the mean life, and that gives us 0.008 as the failure rate. So if you want to use the Excel function, then we want to find the probability that the part will last longer than t following an exponential distribution with the failure rate of 0.008. Okay, so now if the t equals to 80, then we use the 1 minus. So now you should choose the third one, the exponent.dist. So this is exponential distribution. The first parameter is the t value, the 80. The second parameter is d lambda, the failure rate. And then the third parameter is 2, the cumulative distribution function. And now I want to copy this function down for different t values so that you can obtain the reliability at different time points. And therefore I have to fix this C5 cell, this lambda, right? The failure rate is not changing over time. The failure rate is a constant. And therefore you press F4 to actually fix this cell, and then this x value, this t value can be changing over the cells when you copy this down. So now you can copy the formula, and then you will have obtained the reliability at different times. And as you can see, when you have longer time period, when you have a larger t value, then you will have a smaller reliability. This makes sense because you will have smaller probability to survive after a longer length of time period. And now we can also use formula to compute. So the formula in our textbook is defined as the e to the power of minus t over theta. So we can use the exponential function in Excel, exp, and then to the in the power, that is the 0 minus the t over theta. And of course I want to fix this theta because the mean life is not going to change. You press F4. Okay. And then you can copy this formula down for all the following cells, and therefore you can obtain the reliability at t equals to 125 and at t equals to 160. So either way you will obtain the same number, and you can always use the one that you feel more comfortable with. Okay, that's all for today's lab.